So we're kind of nearing the end of this unit, and a lot of the things that we've done really tie into one another. And one of the things that you got to kind of get used to looking at is that there's a lot of different ways to describe a set of data. We can have a table, we can have a graph, we can have a set of ordered pairs that we can all do, that can all represent the same thing, and in the end represent the same function. When we're looking at tables here, we have to realize that, and kind of like in my previous videos as well, is that this is the point where we're going to start to really look at independent and dependent variables. We do note that our first column here, that's going to be our independent variable. That's going to be our kind of like our x values or our domain values. We're going to have to start making this link pretty soon, especially when we get to our next unit. That first column's x, second column's y, first column's domain, second column is range. And we're going to start to get in the habit of just kind of looking at these patterns for these linear relations. We can see that we're going up by 100 each time, and we're going, but for our domain values, sorry, and we're going up by $20 each time, or up by 20 here. And the whole name of the game here is that even though that we could have distance going up by 100 and cost going up by 20 each time, depending on the situation, in this case, it's how many kilometers somebody is driving in a car, depending on the car rental cost, we should be able to, and I always like using this word, but kind of like inject values in between these set of discrete data points. Something like a 232.3 kilometers should be in between these two, and we should be able to figure out a cost from these. So we're really trying to kind of bridge our understanding of not just maybe discrete values, but on the general sense of, okay, now we're going to look at continuous data. It's in an applied context, but we're still going to look at continuous data and how can we kind of represent tables, ordered pairs, graphs, and how can we sort of get an equation from that. This unit isn't about getting equations so much as it just getting us to the point where we can start looking at getting those equations. So this is a linear relation because each of our domain values increase by the same amount and our range values increase by the same amount. We can see this on our diagram. Or on our graph. If we were to graph this out, we're using a continuous line here. I would be okay if I wanted to extend this out. If I wanted to put an arrowhead on it, that would be fine. But take a look at every single data point goes by the same amount. However, we could also say that if we wanted to, say, skip a data point, and let's say we wanted to go 200 of an increase of value, well, then we would have to double our increase in terms of our y value. So we would have to double this. So this would be equal to something like 200 and then 200 and then 40. This would be 200 over here, and this would be 40. And that is proportional to how we are looking at this car rental cost. Even though we're going up by 100 or across by 100 and then up by 20, that's the same as going across by 200 and up 40. We could do it another way by saying, hey, let's go across 400 and then up 20, 40, 60, 80. And that would all be proportional because this is a linear relationship. If we're looking at ordered pairs, we can just kind of look at sort of leapfrogging our domain. This is plus 100, and that should stay constant. Plus 100, plus 100, plus 100, right? If we're looking at our range, we could say the same thing. Plus 20, plus 20, plus 20. And this is what it means to be a linear relation. We kind of described this in grade 9 quite a bit, the linear relations, but we're really going to continue on with this in grade 12 or in grade 10 as well. Finally, I just kind of want to talk a little bit about making an equation. An equation is something that you're going to have to do sometime in this course. We're going to have to make equations. And the easier that we get at doing that, or the faster we get at doing that, the easier it's going to be. Equations have to have a couple things. They need to have two variables. Usually it's going to be x and y. That's really what our next unit is going to be, x and y. In this case, we're going to use two different ones. We're going to describe our distances as lowercase d and our costs as uppercase C. So in our case, we can use that. But when we're making an equation, and specifically a linear equation, we always want to start with the dependent variable. We always want to start with our y, or our dependent variable. And it kind of goes something like this, where our dependent variable is going to equal to our rate of change, and that's going to be multiplied by our independent variable, d, and that's going to be adding on to our initial value, plus starting, or you can say initial value. And again, this start value is for our dependent variable. So let's take a look at what the rate of change for this is. We know that the rate of change is going to be, let's calculate it just off to the side here. Our rate of change here, it's the ratio between how our dependent variable changes by our independent variable changes. And we've kind of said that our dependent variable changes by 20, or values change by 20 each time, plus 20 every time. And our independent variable changes by plus 100 every time. That's 20 divided by 100. That's 0.2. Now, what does this rate of change mean? It relates what the units are for our dependent and relates the units to our independent. So this was actually plus $20 over 100 kilometers. So we're really comparing that you're going to get charged, or the rate of change is $0.2, 20 cents, and we say this is per kilometer. 20 cents per kilometer. So we kind of read this rate of change. Now, this isn't going to be really the focus of our unit, but this will become the focus of our unit during our next unit. And it's very, very related to what we're doing here. All of these things, the table, domain, x, continuous, our ordered pairs, our graph that looks at our line, all of these things relate back to having an equation and having a function that relates these. And it comes from relating our dependent variable to our independent variable and using things like the rate of change and our starting value, or our initial value, which, by the way, our starting value here is when our independent variable is 0. So our starting value would be 60. So like our equation for this one, if we wanted to write it all out, would be C is equal to 0.2D plus 60. And you'll see in the notes what each of these things kind of represent again. But I wanted to kind of give more of an explanation of why these things are important and how we're going to be moving along this course so that ultimately we can get to building these equations by ourselves and then using them further afterwards.